Hello everyone, I'm Wanling from Shenzhen University, China. This is a joint work with Jixiong Liu, Jiakun, our advisor Weike, Professor Zhong Ming from Shenzhen University, and also with Bo Liu and Professor Qiang from Hong Kong University of Science and Technology. Our work is about personalized news recommendation. As we know, this has been one of the must-have services for most mobile device users, which plays an important role in helping users keep up with the current affairs in the world. In this program, we focus on recommending latest news articles to new users, and we propose a solution called neighborhood-based transfer learning for this new problem. And that transfer knowledge from app domain to the news domain, I will explain it specifically later. So this is our title. Now let's look at our problem. In our study news recommendation problem, we have two domains, including an app domain and a news domain. Firstly, in the app domain, we have a set of triples. This denotes that user U has installed how many types of mobile apps belonging to the genre G. Secondly, in the news domain, we have a set of quadruples, like this, which denotes that user U has read an item I belonging to a level 1 category and level 2 category. The level 1 categories are coarse categories, and the level 2 are fine-grained categories. In our problem, we only use items category information but not content information. Our purpose is to recommend a ranked list of latest news articles to each new user. New users means they're newly registered in a certain recommendation service and have not read any news articles before. And the latest news articles means they have not been read by any users before. Thus, we can see that it is a new user co-start and new item co-start problem. So we name it dual co-start recommendation. And this is our illustration of this problem. In this picture, the data of the app domain can be represented as a user genre matrix G. In this matrix, it contains the information of warm start users and cold start users. Then we will use them to construct the neighborhood for each new user. On the left, we can see that we have a user item matrix R denoting whether a user has read a news article. In our data of news domain, each article I is associated with the level 1 and level 2 category. So after pre-processing, we have a user category matrix C, where each entry denotes the number of news articles belonging to a certain category that a user has read. After that, we try to transfer knowledge of neighborhood from the app domain to the news domain, and then predict new users' preferences and recommend a list of news articles to them. The main difficulty of our problem is the lack of preference data for new users and new items. Specifically, there are two challenges, including the new user co-start challenge, because the target users have not read any items before, and the new item co-start challenge, as the target items are not very new for all users. Under such a situation, most existing recommendation algorithms are not applicable because most of them rely on users' historical reading behaviors and news articles content information, but that are not available in our case. So that is why we turn to address our problem from a transfer learning view. Although there are no users' behaviors about the co-start-users and co-start-items in the news domain, there may be some other related domains with users' behaviors. Then we think of app domain, where the user app installation behaviors are available. We find that most co-start users in the news domain have already installed some apps, and that may be helpful in determining his or her preferences in news articles. For the new item co-start challenge, we designed a category level preference to replace the traditional item level preference, because the latter is not applicable for the new items in our program. Speaking of the advantages, our method can make use of the user's app installation behaviors for news recommendation in a simple but effective way. Then we will have a look later. And this table shows the notations. These notations will be used in our prediction loops. I will explain it later. And these two are used in our baseline methods. And this one is a set of neighbors of user U. We will use it later. For our study dual co-start recommendation problem, we cannot build correlations between a co-start user in the test data and a warm start user in the training data using the data from the news domain only. The main idea of our transfer learning solution is to leverage the correlations among the users in the app domain, with the assumption that users with similar app installation behaviors are likely to be similar in news taste. For example, two users with the installed apps of the same general business may both prefer news articles on topics like finance. Therefore, with the cross-domain preference assumption, we first calculate the cosine similarity between a co-start user and a warm start user in the app domain as follows. In this formula, user there is from the user general matrix G in the app domain. Then we can construct the neighborhood for each co-start user using the cosine similarity. We first remove users with a small similarity value, like some value less than 0.1. Then we take some most similar users, about 50 or 100 users, to construct the neighborhood. Now we have a knowledge of neighborhood from the app domain. The next step is to find the user's preference. In most recommendation methods, the similarity between user or item is a central concept, because the neighborhood can be constructed for like-minded users' preference aggregation and then for the target user's preference prediction. Mathematically, the item-level preference prediction loop for user U to item I is as follows, like this. The set of nearest neighbors of user U has been calculated using cosine similarity measurement before. And R with hat is the estimated preference of these user's neighbors to item I. But we don't have a score for item level preference because the item I is new for all users, including the warm start users and cold start user. So we use a category level preference to approximate the item level preference. The category there can be the level 1 or level 2 category. Then we have two types of category level preferences. In this equation, N denotes the number of read articles by this user, and those articles belong to these two types of category. Eventually, we can rewrite the item-level prediction rule as follows. According to these prediction rules, we can calculate new users' preference. Both two types of category will be used for preference prediction in our experiment. Through the preference results, we can get a ranking list of news articles and then recommend it to the target user. A simple way to transfer knowledge of neighborhood in app domain, right? But it do adjust the new user code start challenge. In the category level preference, adjust another code start problem, new item code start challenge. Simple but truly effective. Now let us have a look at the experimental results. In our empirical studies, we use a real industry data, which consists of an app domain and a news domain. In the auxiliary domain, app domain, we have more than 800,000 users and 53 genres of the users installed mobile apps, where the genres are from Google Play. As for our news recommendation, we removed 14 irrelevant genres such as tools, communication, social, entertainment, and so on. Then we have a matrix G with this size, where each entry represents the number of times that a user has installed apps belonging to a genre. And in the target domain, news domain, we have two sets of data, including a training data and a test data. The training data spans from 10th to 13th January this year. We can see that a user has read about 20 articles on average during this period of time. The test data are from the data of 31st January, which contains about 3,600 new users. We can see that a cold-start user read about 1.3 articles this day. And also, we have 26 level 1 categories and the 222 level 2 categories about news articles in the news domain. And for performance evaluation, we adopt some commonly used evaluation metrics and ranking-oriented recommendation, such as precision, recall, F1, NDCG, and one call. Specifically, we studied the average performance of the top 15 recommended list, generated for each cold start user in the test data. Then we compare our solution with the random method and two popularity-based methods using category information. We also use two types of categories. In pop rank methods, for the most popular category, there may be more than k articles in the test data, and this k equals 15. We then randomly take k articles from that category for recommendation. And these are our experimental results. Let's take a look. From this table, we can see that our proposed transfer learning solution shows effective performance. On the other hand, the performance of pop-rank methods are rather poor in comparison with our proposed solution. The reason is that they are non-personalized methods, which ignores the difference in users' news reading behaviors. In addition, in our transfer learning methods, NTL, we can see that using level 1 categories performs better because the level 1 category may introduce more smoothing effect for the cold start problem. Then, we further study the impact of the neighborhood size. Through this figure, we can see the performance of our NTL with Level 1 category, using 50, 100, 150 neighbors. The results are relatively stable, like this, and fixing it as 100 usually produces the best performance. And then, in order to gain some deep understanding about the transferred neighbor, we randomly choose the same number of neighbors in our NTL with Level 1 category and study their performance. The results are shown in this figure. From this, we can see that using the app installation behaviors in the app domain, the neighborhood is better than that of the random one. So it shows that the two domains are related and can indeed transfer knowledge from one domain to the other. In conclusion, we study an important and challenging news recommendation problem called dual co-start recommendation, which aims to recommend latest news articles to newly registered users. Specifically, we propose a neighborhood-based transfer learning solution which is able to address this two co-start challenge. By the transfer neighborhood from the app domain and the category level preferences in the news domain respectively. For our future works, we will select some representative genres and categories in two domains and build a mapping between them, which will be further used to study the neighborhood of the items. If you have any questions and suggestions, welcome sending us an email. Thank you.